system to remove frost or ice built up from evaporator. It's worked by redirecting high pressure gas from the compressor directly to the evaporator by passing the condenser. This hot gas melts the frost or ice on the evaporator, restoring and its efficiency. This method is energy efficient and quick compared to other defrosting techniques. It's commonly used in industrial refrigerant system, especially in environment where maintaining consistent cooling is critical, like cold storage facilities. Next. This is meaning of the frost. Frost is referred to the thin layer of ice that form on surface when water vapor in the air conditioning and freeze. This typically happens when the temperature of the surface drops below the zero of water. Frost is commonly seen on cool objects like glass, window, or evaporator coil in a refrigerant system. Okay, next.
What is defrost? Defrost refers to the process of removing frost or ice that has formed on the surface. Often in refrigeration, to the freezing system, frost build up on the evaporator coil due to moisture in the air freezing, which can reduce the efficiency of the cooling system. To combat this, defrosting is periodically done to clear the ice build-up and restore proper moisture.
Ice without
it melts the ice more efficiently and quicker than if the defrosting was introduced.
We use the high pressure gas from the compressor directly through the solenoid valve.
So we go to the type of hot gas defrosting. Hot gas defrosting have two types. First, we have the hot gas reverse defrost, and at the second, we have the reverse defrost. Okay, next, we go to the first type. That is the hot gas bypass defrost. Okay. So there is bypass line in the hot gas defrosting. The bypass line is installed between the compressor discharge tube and the evaporator. So that means the bypass defrost design, it will have the bypass line from the discharge compressor to the evaporator. It will direct to the evaporator. And then, as we know, in discharge line, there is high pressure and high temperature. High temperature and high pressure gas. So we will go through the evaporator to melt the frost on the evaporator. And then, we can see here the hot gas bypass defrost is controlled by the solenoid valve. Electronic control valve. This is solenoid valve. So the hot gas from the discharge line will be controlled by the solenoid valve. So if the surface of the evaporator has defrost, so solenoid valve will open and then through the hot gas to the evaporator to melt the frost on the evaporator. Okay, next.
So, what control the flow of gas through bypass line for defrosting? Okay. Hot gas solenoid valve is an open state. The high pressure, high temperature, high pressure refrigerant flow through the bypass line and the solenoid valve directly goes to the evaporator. At this time, the evaporator acts as a condenser.
diagram. Reverse cycle defrost is another kind of obvious defrost. It achieves defrost by changing the refrigerant flow direction in refrigeration cycle. That means in reverse cycle defrost, the condenser acts as evaporator, while the evaporator acts as condenser. The hot gas defrost operation is the opposite of the refrigeration cycle. Next. Okay, these are the advantages of hot gas defrosting. First of all, it's quick process. Frost much faster compared to other methods. Second, we have energy efficient. Utilize the system internally without extra energy consumption. And the last one is minimal downtime. Ensures consistent cooling operation, especially in industrial settings like cold storage or supermarket.
For our conclusion about hot gas bypass defrosting, this hot gas bypass defrosting is more efficient from other defrosting method. So because it use the hot gas from the condenser directly to the evaporator, reducing energy use and temperature fluctuation. This method also can enhance system performance and sustainability, make it